with the Spring framework in an easy way. Now, before you use Spring Boot, you need to understand what the Spring framework is all about, and that's exactly what we'll discuss fairly quickly here in this video. It's assumed that you have some familiarity with Spring, but if you don't, you can get started here. If you've been a Java developer for any length of time, it's quite likely that you've used some component or the other which is part of the Spring framework, because Spring is a Java framework that provides a convenient way of integrating disparate components into a working enterprise grade application. The Spring framework relies heavily on inversion of control to bring these components together. Managing dependencies within your application is a hard task, especially in Java when you have a number of libraries that you could depend on to get your task done. Inversion of control implemented using dependency injection makes this easy in Spring. A common scenario which you might have encountered is to use Spring modules such as Spring MVC to build web applications. But Spring is so much more. Spring refers to an entire family of projects which support a wide range of applications. Spring supports a wide range of enterprise grade applications, whether they're web applications, long running batch processing jobs, or any other kind. You can use Spring with simple cloud hosted servers, standalone batch workloads, and integration workloads. A common factor that you'll encounter across all enterprise grade applications is their complexity. There are different components which perform different actions, and these components have to interact with one another. These components might be dependent on one another. Managing dependencies is an important part of any application. Handling and managing these dependencies and ensuring that every component has access to all of the classes that it depends on is an important part of application development. Now, dependencies cannot be managed in an ad hoc manner. This will suffice for simple dependencies, but within an application, this will soon get out of control, which means you need some kind of design pattern to manage these dependencies. Now, design patterns are great and they help you build robust applications. However, design patterns are often not sufficient by themselves, because design patterns tell you what best practices you need to follow, but you still need to implement them. The onus or the responsibility is on the developer to implement these design patterns. This means if you're working on a large team of developers, it's quite possible that inexperienced members don't follow the pattern perfectly. You need a way to shift the responsibility from developers to the framework, and this is what Spring does so well. Spring uses inversion of control, or IOC, implemented using dependency injection to free the developer from the burden of managing dependencies. When you use the Spring framework, you can configure the components of your application using either Java annotations or XML configuration files. A component simply has to declare its dependencies, and the Spring framework will take care of ensuring that the component has access to the classes that it's dependent. There are a large number of Spring modules available that allow you to work with Spring, where you write just simple methods to perform very complex tasks. For example, let's say you need to connect to a database and run queries on this database. Spring allows you to set up database